So I welcome you to in this another video tutorial in the series of computer system architecture. And so in this lecture I'm going to explain you the examples of don't care conditions. So what are the don't care conditions? Don't care conditions are the conditions for which we don't care about whether it is 0 or 1, right? Whether it is 0 or 1. So you know the what are the minterms are, right? So minterms are the cell values which are in these Karnaugh map, right? So these are the cells like I have two variable Karnaugh map, so in which we have these minterms like 0 1 0 1. So first minterm is xy, which is x0 y0, means 0 0 0 1 1 0 and 1 1. So 0 1, so for 0 1 x complement y, for 1 0 it will be x y complement, and for 1 1 it is x y. So these are the minterms. For if I have like this minterm is present here, so it is 1 here, it is 1 here, right? And for these two minterms we don't have any conditions. Okay, so if in your example in case it's given like f x comma y sum of minterms, this is like, so here we have 1 0 means x y comma x 1 y 0 is 2, right? And for we have 0 1 we have 1. So this is the equation for which we have this representation of Karnaugh map, right? What I have done is that for this Karnaugh map I can write this equation, right? And to represent this equation I can represent it in this K map or Karnaugh map. So this is the simple Karnaugh map which is given to you, and in questions they are asking you that to simplify this equation, right? So for that we cannot make a group of these two ones because they are not in line, or they are not because they are not in the adjacent cells. So if that one would be present here or either here, so in that case we can make a group, otherwise we cannot make a group, right? So you know that how to make a group. So the concept is the don't care condition, right? So if in case it is given in this example that also with this also they have given you like the don't care conditions is 0. Don't care condition is only this 3, right? So they will ask you in exams like that, f x y. I just rewriting this thing as f x y sigma 1 comma 2 plus d3. So d represent here, what d represent? D represent the don't care condition, right? So this is the don't care condition. So for the don't care condition I just told you in my previous video and today itself that for the minterms for which we don't care that if we put 0 or 1, so we can we will put 1 if we want to evaluate the expression in sum of products, and if I want to calculate this expression in the form of product of sum, then I will evaluate, if I will specify this 0 at this place. Okay, so here we have 1 comma 2, so 1 comma 2 we have already assigned 1 at these two places, at position 1 and position 2 in the Karnaugh map, right? And if we so the question is how how to use this don't care condition in this Karnaugh map. So the don't care condition is for cell 3. So cell 3 is 1 1. So here we have 1 and here we have 1. So for 1 1 we have don't care conditions. So don't care conditions are represented either by cross or by D. Okay, so don't care conditions are specified or represented, right? Specified or represented using this cross symbol, right? Or D, that stands for don't care. So we write in the boxes as cross. So the crosses represented the don't care condition, and we will, for our simplicity or for our simplification, we can put here 1 or 0. So because we are evaluating these expressions for the sum of products, so I will put here 1, right? So I will put here 1. So let's assume that x is 1 here. So what it will be? The grouping will be like for these two minterms and for these two minterms, right? Okay, so what will be the simplification now? The simplification will be f x comma y. So for this group it will evaluate to x, and for this one, for this group it will evaluate to y, right? It will evaluate to y. So it will be x plus y. So that will be our simplification or our solution for this equation. Okay, that is given in your that is given to you to solve this, right? So let's take another example, right? So the another example is like you have given, the question is f a comma b comma c equal to sum of minterms or sum of product is 0, 2, 6. So they have given like that, right? Now, and the don't care conditions are given like plus a D. Let us represent these don't care conditions in black, right? So D is 1, 3, 5. Okay. Now, because this is the 3 variable function, so how many cells will be there? How many cells will be there? So the number of cells will be 2 to the power n. N is the number of variables, so we will put 3 here and 8, right? So 8 cells. So that means the Karnaugh map will have a representation like this, in which we have to divide this K map into 8 cells, right? So here we have this. These are the 8 cells. Okay, and for the further simplification, we will put A here and BC here, right? So 0 will be here and 1 will be here. And for this, as you know, and if you don't know how to simplify or how to represent these combination of zeros, so you can watch my previous lectures on Karnaugh map. So 0 0 and then it will be 0 1. It will be 1 0 here and it will be 1 1 here. And you know the reason, because these two adjacent cells will be differ by only 1 bit. So that's why we have we don't put 1 0 here but 1 1 here, because if I put 1 0 here, you know that 0 will be flipped to 1 and 1 will be flipped to 0. So it will differ by 2 places. So then it will violate the rule for Karnaugh map. So that's why we represent in this way, right? So let's say we have 0 to 6. These are the minterms that we will specify 1 in this Karnaugh map. So for 0, so as we know that let simplify this as much as I can for you, that 0, this is 0 minterm, 0 cell, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6, and this is 7, right? So you don't need to write these numbers. Actually I'm just writing these numbers to just to explain in much better way if you really don't know that how to represent the cell and how to represent these numbers that are given in your questions in this K map. So okay, now you know that how it is. This is nothing but this is the combination of these 3 zeros are zeros. The 0 0 1 is 1, 0 1 1 is 3, 0 1 0 is 2. It's just the binary to decimal conversion and nothing else. So the 0 is present here, so we will we will specify 1, and then at 2 we will specify 1 here. At 6, okay, at 6 we will specify 1 here, right? Okay. Now for these don't care conditions we have 1 3 5. So at 1 we have this don't care condition, at 3 we have this don't care condition, and at 5 we have this don't care condition. Okay, so now let's see that how to simplify with this. So they are asking about the sum of products. Why sum of products? Because they are given it is this symbol. This symbol is known as sum of products. And on the other hand, if they want to be evaluated is this as a product of sum, so they will specify in the question that you have to evaluate the product of sum form, and you know the sum of product and product of sum form. What is the difference between these two? You can watch my previous video, right? Video number 5. Okay, so let's start. So in this Karnaugh map representation, so how the cells or how the grouping will be. So for the grouping, because the maximum number of cells is 8, so we can make a group of 8 cells, which is possible only then when we have all the ones at all the places, because these are all these cells are 8 in numbers. So this is not possible in our case. So, and we know that we will make the group in multiples of 2, so we can make a group of 8, we can make a group of 4, then we can make a group of 2. Okay, right? And so like that. So 8, the group of 8 is not possible, group of 4 is possible, so we just need to check it out. So here we have 1, here we have 1, at these two places we have don't care. Okay, so what we will care in this case, we will care the x like 1. So if I assume that there is 1, so we can make a group of 4 here. So this is possible to make the group. So let's make a group of these 4 cells, right? So we have made a group of these 4 cells now, and which will be evaluated to A complement, right? A complement, because these all with the rules of Boolean algebra, as you know, if you evaluate this expression, so it will be evaluated to 1. So A complement and 1 will be A complement. Okay, and then again, then if I check that if there is any possibility of another 4 group, there is no possibility. So again we need to check that there is the possibility of group 2. So we will see that yeah, this is the possibility that we can make a group of 2, right? So here these two minterms will be grouped together. So what will be the expressions now? If I put it here like that, for this we have A complement, B complement, C complement plus A complement, B complement, C plus A complement b c plus a complement b c complement. And for this expressions we have again we have this, we have to write this again. Okay, so for this we have a complement b c complement plus we have for this min term we have this a then bc complement. So I have written out all the min terms that we had, we are going to group. So to further explain it, so I have written it in full forms. So I can also write it directly, but this is for explanation. You can write it directly, okay, because you know it, and if you practice well and you will know. Okay, so here we have a complement, b complement, c complement. The common will be the here a complement and b complement. Here like if I use the different color for you to explain it in better way. So I have this is the common in these two, because c plus c complement will be 1, because we know the rule is x plus x complement will be 1. This is the rule. Okay, so we have this common a complement b complement, okay, plus in these two statements we have this common a complement b and a complement b. So we have a complement and b plus in these two statements we have bc complement, bc complement common here. So we will write bc complement, and in bracket we will have a complement plus a complement plus a, or a plus a complement will be 1. So there is no need to write that, but in your exam you can write it. Okay, so here again we come up with these three min terms after simplification, but let's check if we can also further reduce this term. Yes, we can reduce, because in these two sums we can see here that a complement will be common, right? So a complement, right, because b complement plus b will be 1 plus bc complement, and this is your final answer for this. Okay, so I think it is very much clear to you, and if further you have any questions regarding this, you can ask. So let me draw a logic diagram for this expressions. Okay, because in the exam they will going to ask you about this question, and then they will ask you to draw a Karnaugh map for that, and then you need to simplify, or you need to reduce this K-map representation using the min terms in a very simplified form, and then you need to draw a logic circuit for the simplified expressions, right? Okay, so now I will take another page, right? Alright, okay, so I have this page here, new page here. So for this expressions, so let me write this expressions again here. F is equal to a complement plus b c complement. So can you guess that which gate will be used? Which gate will be used for these for the above equation, or for the above simplified expressions, right? So the gate will be, because here we can see that there is a plus operation, and the plus operation simplifies for OR gate, and here we have this dot b dot c complement. So dot specify the AND gate, right? Dot represent the AND gate. So these things you need to remember, right? that what is this, and if you don't know about this, that how I'm saying that this is plus is represented for OR gate and dot is for AND gate, you can watch my previous videos on logic gates, so that will be enough for you to understand these concepts of OR and OR, right? So here we have this, let me write this like A, B and C. So first of all I will calculate this, right, for B C complement, right? So for B and C complement, right, a C complement will be this because it is the inverter, right? So B and C here, there will be AND gate between these two, right? Because we are doing a dot product, and that is your AND gate, right? And for this A will be, again we will calculate the using the inverter gate A complement. Okay, so here and these two, A complement and B C complement, will be then act as an input to this OR gate, and the final expressions will be evaluated like that. So this is the logic diagram, right? This is the logic diagram, right? Logic diagram for this above equation, right, or above expression. So you can draw logic diagram like that. Again, for further simplification, you will see that here is A, it will invert it, and then it will become A complement. Here we have B, and C will be again complemented here because of this inverter, and it will evaluate to as B dot C complement. It will be like A complement, and then these two will be, because this is the OR gate, so they will be A complement plus B C complement. So I hope this concept is very much clear to you, right? Okay, so and you can also solve some questions based upon this, and that will be good for you. And if you practice some questions, you can discuss the answers with me, okay.